Talk about organic chemistry. Now, this video is for those of you who are taking the first semester of organic chemistry in college. Organic chemistry focuses on organic compounds, compounds that contain carbon atoms. Now, carbon likes to form 4 bonds, but you also need to know the number of bonds that the other elements like to form. So elements in the first group of the periodic table, like hydrogen, they like to form 1 bond. Beryllium, for example, likes to form 2 bonds. Boron, which has 3 valence electrons, it likes to form 3 bonds. Carbon has 4 valence electrons. Carbon likes to form 4 bonds. Nitrogen likes to form 3 bonds in organic chemistry. Oxygen likes to form 2. And elements like fluorine and the other halogens, chlorine, bromine, iodine, they like to form 1 bond. Now, there are cases where chlorine, bromine, and iodine can form 7 bonds. But we're really not going to cover that in this video. I do have another video entitled Lewis Structures, which goes into that detail for those of you who might be curious. Now, understanding this is important because it helps us to draw Lewis structures. So for instance, let's say if we want to draw the Lewis structure of water, H2O. Knowing that oxygen likes to form 2 bonds and hydrogen likes to form 1, we can start with a structure that looks like this. Now, oxygen likes to have 8 electrons. Each bond represents 2 electrons. So that's a total of 4. To get to 8, we need to add 2 lone pairs. So that is the Lewis structure for water. Now, the bond between hydrogen and oxygen is known as an H bond, or a hydrogen bond, which is a special type of covalent bond. Hydrogen bonds occur whenever H is directly attached to nitrogen, oxygen, or fluorine. Hydrogen bonding explains why water has such a high boiling point. Now, let's say if we have methyl fluoride. How can we draw the Lewis structure for that molecule? So we know that carbon likes to form 4 bonds, so we're going to put that in the middle. Hydrogen likes to form 1 bond. Fluorine also likes to form 1 bond, so this is the best Lewis structure that we can make. And if you want, you can add 3 lone pairs to fluorine so that it has 8 electrons around it. Elements in the second row, like carbon, nitrogen, oxygen, and fluorine, they like to have 8 electrons. They don't always have to have 8, but ideally speaking, they like to have 8 so that they can be stable. But that's the structure of methyl fluoride. Now, the carbon-fluorine bond is a polar bond. Carbon has an electronegativity value of 2.5, and the electronegativity value of fluorine is 4.0. Whenever the electronegativity difference between 2 elements is 0.5 or more, the bond is said to be polar. So this is a polar bond. It's not a hydrogen bond because fluorine is not directly attached to hydrogen, but it's a polar covalent bond. Now you might be wondering, what does it mean for a bond to be polar? A polarized object is an object that is neutral overall, but has charge separation. That is, one side is positive and the other side is negative. So this is a polarized object. The bond is polar because fluorine carries a partial negative charge due to the fact that it's more electronegative than carbon, so it pulls electrons toward itself. And carbon, being less electronegative, has a partial positive charge. So due to that charge separation, we can say that the carbon-fluorine bond is polar. Now, the carbon-hydrogen bond, that's a non-polar bond. The reason being is the electronegativity difference between carbon and hydrogen is less than 0.5. Carbon, we said its electronegativity value is 2.5. Hydrogen is 2.1. So the difference between the two is 0.4. So understand this, anytime you see a hydrocarbon or a bond that contains carbon and hydrogen, those bonds are nonpolar bonds. Because sometimes you need to determine if a molecule is polar or nonpolar. So, for instance, methane, CH4, that's a nonpolar molecule because it only contains carbon and hydrogen. So far, we've considered two types of covalent bonds: polar covalent bonds and another special type, which are hydrogen bonds. And we also talked about nonpolar covalent bonds, like the carbon-hydrogen bond. That's a nonpolar covalent bond. But you need to understand the difference.
So as I was saying, ever since I switched to Lecturio, I've felt empowered, like I can study anytime, anywhere, and for the first time I really feel I can choose how to learn, you know what I mean? Like, let's say I want to study anemia, I can stay classy and read using the concept pages, or I can go and use the interactive video lessons. But hey, let's say I want to study more actively, right? Well, then I can use the quizzes with the spaced repetition system to help me memorize, or I can go straight to the QBank and test myself using a clinical vignette. And of course, over there I can change the difficulty, the subject, the number of questions, and even choose whether I want an AI tutor to help me through the cases. Like, what? Sir. Oh, and as if that wasn't enough, I can even follow my own study plan or choose one created by their experts. In fact, I was thinking about starting the 40-day study plan to prep for step 1, but I don't know. What do you think? Sir, I just wanted to know if your Wi-Fi was working.
جاكوار لايرز فك الشفرة حلو ليمون هوبا زبطة.
That's a nonpolar covalent bond. But you need to understand the difference between a covalent